So let me start then with thinking about how we create new forms of engagement with computers. In this case, opening up the space for interaction with new kinds of input devices. So there's no doubt that input techniques have brought about revolutionary change, not just in how we interact with computers, but the kinds of devices that we build and the kinds of tasks that this makes possible. Yet outside of the research world, it's really only in the last few years that mass market devices, anyway, have made the next big leap beyond keyboard and mouse. So with the iPhone, suddenly we find multi-touch taking off, and this is inspiring all kinds of new classes of computing devices. Hot on the heels of this, we then saw gesture-based transforming the way that we think about interaction with computers. And obviously, the Kinect gaming technology is a good example of this, in the way that we can interweave keyboard and mouse interaction with the gestures that we do. Okay, so that was the first thing. Another big concern was that we wanted these gestures to be ergonomic. Okay, so what we don't want here is kind of Tom Cruise Minority Report holding his hands out for a long period of time, because actually it's very tiring to do that. And also thinking about leveraging the power of in-air gestures. So what gestures are good at are being very casual and expressive. What in-air gestures are not good at is being precise. So anything that's very precise in front of the screen, touch is good at that. Mouse pointer is good at that. We don't need to do that with gestures. Okay? And then exploiting the power of two hands. So one of the things that I said earlier that multi-touch lets us do is to use two hands. Well, also, if we can add gestures to the interface in front of the keyboard and mouse, we can perhaps use one hand for a gesture while we leave the other hand on the mouse. So it's trying to exploit that. And then finally, we wanted a gesture set which would have a good mental model so that it would be easy to learn, but also that people could remember it in the long term. So we had a bunch of things that we were working with.
Our system is general in its approach to sensing hand gestures and touch. The Kinect camera captures raw depth data of interactions occurring on the desk. An adaptive foreground segmentation allows us to isolate the hands. We then use a random forest space classifier to identify salient features of the hand, as well as detect the hand pose. Each pixel in the foreground image is classified as either fingertips, shown in pink, the wrist, shown in grey, or the overall hand state, which transitions between different colours as the user performs different gestures. The different hand poses that we can currently classify are shown in sequence. With synthetically generated training data shown in set, this allows us to classify a variety of hand states without requiring full hand tracking. To determine a specific hand pose from this label data, we first compute a histogram for each hand across all hand states and select the state with the highest frequency. Using this approach, we can create a gesture recognizer easily by just observing the presence of a specific hand state for a certain number of frames. More complex gestures can also be developed by observing transitions between multiple hand states.
And we're calling this a 2-foot PC project because one of the motivations here was really technology push in this instance. In other words, we asked ourselves the question, what would we be able to do with a computer if we could see in the proximal space around keyboard and mouse?